In this second video, I will perform the registration that we started to create on the first video, and I will continue to adjust the parameters to fit this one in this one. So for now I will not add landmarks because I think we can manage to match this into this without landmarks. So I will just open the main registration section and I will start to manipulate the parameters. So there are just 4 parameters which are the so this is an iterative process. So here you can adjust the number of iterations, and then all these parameters will be used. So the sampling parameters is will represent how the percentage of points used for each mesh to so basically if you reduce this sampling, the process will be faster but less accurate. So usually you will always need to put this to 1 to have the final result. Search distance is when the solver will compare both meshes. It will just pass all the points from this one and try to find correspondence on this one, and it will search by distance but also compare many similarities between both meshes. So there are plenty of features that has already been computed by the nodes in order to compare both meshes. So the solver compares both meshes alternatively in both directions. So the search distance is when for example, when the solver start to compare this point and search correspondence on this one, the search distance is how far it will search on the mesh. So increasing the search distance will allow the node to search further, but the higher the distance, the more likely you can have some overshoot in the result. So this is why we have a stiffness parameter which controls how this mesh will resist to deformation and try to preserve its shape while being attracted to this one. So the higher the stiffness, the smoother the result. So usually when you increase the search distance, you will have to increase the stiffness as well. So let's start with a few iterations. So you can see that already with a few iterations and sampling that is only 80%, it's already starting to work. So I will just increase the iterations. So when you increase it, you can see that there is a yellow line here. When you increase the iterations, it will only compute from the current iterations to the one you set. And now if I drag, this yellow line represents all the iterations that have been cached. So there are in memory cache, and I can just drag here and it's moving in real time. but as soon as I will change any parameter from here, it will just recompute everything. So I can add a bit more. I will reduce maybe the stiffness, because I can see that here I would like this zone to be attracted more, so I will decrease the stiffness. Maybe increase the search distance. So if I want to modify several sliders, the better is to put this one to 0. I will just add a full sampling. I will increase the distance and decrease the stiffness and just perform again. Okay, so we can see that now we have a much better shape. And so this mesh is starting to look like this one already. So at this step we can usually go to the next step, because the next step, what I call the refinement, is quite efficient on its own. So it's a bit like a Maya shrink wrap, but it's more intelligent in the sense of it will account for both meshes normals. So and it searches in many directions. So let's try to add. So this also is an iterative process. So it will project the point of this one on this one. We'll try to find the best. It's not only the closest point, is it will also search in a wide area and try to find the best match from here to here. So the search distance parameter here is quite the same effect as this one from the previous step. Then for each projection iteration you have a relaxation step, which is basically a Laplacian smoothing, but more like a delta mesh spirit. So it just relaxes the points and pushes them back, so we preserve the volume. So that's why we have this parameter, relax, volume, preserve. So usually you won't have to touch this parameter usually, so you can just set it between 0.8 to 1. And the pin relax tolerance is when you have set up some landmarks, it's how much you allow these landmarks points to relax along with the other points. So let's add a few iterations here. So I will toggle the smooth. So you can see that it's almost done now. So yeah, it's done. So I will just show you how the parameters affect the result. So if I increase the relax, it will just relax the result, but but make sure that this volume preserve. If I reduce it, you can see that for the tail, for example, it shrinks a bit, so it's better to push this to the max. So if you want to have the best quality, it's better to reduce the relax and increase the main refine iterations. So we can see that it's done. So I will show you in another video how to use landmarks, but you can see that here we didn't need to use any landmarks. And actually I can open some other examples, more complex. For example, this one. So the two meshes you will see are more dense. They have like 10,000 points each. So this is why the process is slower. And in this scene we don't have landmarks at all. So in this scene we have registered this head on this one. So the goal was to match this topology on this one, and this is the result. And well, you can see that it's also perfect, and there are some differences, but this is because this mesh has less points. So if I review the attributes, we can see I will just reset the refinement slider. So this is the result from the main registration. You can see it's not perfect already, but the refinement did enough to perform the full result. So if I just go back in iterations, you can see that it's deforming pretty well. So the eyelids has been attracted to the right location because the main algorithm compares, it just find out that the lids of this one should go on the lids of this one. I don't want to give too much details about the internal process for obvious reasons, so it just works. So I could have increased the iterations here, and the result would have been even more accurate, but for your own use, just try to adjust the refinement regularly, because you can see that it's doing a very good job by itself. And actually, if I reopen the horse example, I will just skip this. And if I reset all, and I will just skip the main registration step and just use the refinement. increase the search distance, increase relax. So you can see that here the result is not perfect, but it already has done a great job. And if you had used shrink wrap from here to here, the result would have been just a mess, because these legs would have been just put flat on this side. And so this solver is way more evolved than just a shrink wrap. Okay, so this is it for this video, and in the next ones I will show you how to use the pin pairs when you have more, when you can't achieve your result using all we just reviewed. You can add landmarks, corresponding points between both meshes, and they will just guide the deformations. And usually you won't need to add more than, I don't know, 2 to 10 landmarks maximum, because there is a whole weighting system that you can customize for every landmark. Okay, so see you in the next video.